Bismillahirrahmanirrahim and Assalamu alaikum. I'm Hassan and in this presentation I will be discussing Bayes rule or Bayes theorem. I will first explain the basic idea of this rule, how it works, why it works, followed by its significance and importance in our day-to-day lives, and how we can basically employ Bayes rule to calculate chances and probabilities of various events. So let us start. What exactly is Bayes rule? In the simplest term, we can define Bayes rule as a method or a way to find the probability or likelihood of any event based on certain probabilities that are already known to us. It's like we want to find the likelihood of some outcome from an event based on some other event that has already occurred. In more formal terms, we can say that it is a revised or updated probability given new or additional evidence or data that will basically alter our outcome. The formula for Bayes rule is pretty straightforward. If we look at it, on the left hand side we have the conditional probability called the posterior, which is the probability of any event that we are trying to determine or to estimate. And on the right hand side, in the numerator, we have the likelihood of an event, which is basically the probability of observing the evidence from what our initial guesses or hypothesis was. This likelihood is then multiplied with the prior, which is basically the probability of our hypothesis, and is not conditioned on any other additional prior information. And this product is then uh, divided by the marginal likelihood, which is basically the total probability of observing an evidence. Now we will talk about the significance of Bayes rule. So it is widely used in medical sciences to treat and predict various diseases based on large data from previous patients' record, and can also be effectively be used to conclude a specific disease in any patient. Similarly, it is also vastly used in economics and statistics to sometimes predict the rates of potential profits or losses from any investment, or to basically predict the estimates about the stocks or shares as well. And nowadays it is also being vastly used in computer science as well, mostly in artificial intelligence or AI, to basically model and predict the various results based on the data or the evidence collected in the past. So moving on, we can use Bayes rule for both continuous and random variable and discrete random variable, sorry, which represents some sort of event. For this video, I will be focusing on discrete random variable, and I will also discuss the an example of Bayes rule with discrete random variable. Right. So right here is the basic formula for the Bayes rule, where P of A given B is the posterior, P of B given A is the likelihood, P of A is the prior, and P of B is the marginal likelihood. We can also represent this formula by PMF, or probability mass function, for each of the conditional or marginal probability from the above, and it will look something like this, where the marginal probability Py of y uh, or the occurrence of y will be the basically the summation of all the events where y will occur conditioned on some other event k, right? So it is basically the total probability theorem to basically find the total probability of y. So once we substitute this in the formula above, we will get the final result as follow, right? So now let us see this now let us use this Bayes rule that we have derived in an example, so it will be more clear. Suppose that there is a man that speaks truth 2 out of 3 times. So this will be our posterior, as it is known from the previous events. Now this man throws a die, and number obtained on the die is basically 4. So what will be the probability that the number is actually 4, or if he is lying? So to find out, we already have our posterior. So let us represent the event A as the man reporting the number being 4, and E1 be the event that the number is actually 4, and E2 be the event that the number is not being 4. So for any 6-sided die, the probability of E1 should be 1 over 6, and similarly the probability of its complement, or E2, should be 5 over 6. The posterior given is the probability 2 over 3, that is the probability of A given E1, meaning that the person speaks the truth about the number obtained, and similarly the probability of its complement of the posterior will be 1 over third, and that will be that he basically lies about the number obtained. Now using Bayes theorem to find the probability of the number being actually 4, will be the probability of event E1 given A, that is the number obtained is basically 4. So what will be the probability that if the number obtained is basically 4, so what will be the probability that he's telling the truth when we have gotten the 4 actually. So substituting all the values that we have calculated above, we will end up with 2 over 7, which basically tells us the likelihood that number obtained will actually be 4 given he speaks truth 2 out of 3 times. So we see how we can employ Bayes tool to basically predict probabilities of different event. And with this example, I would like to end this video. I hope you like this video, and please let me know if anything is unclear in this video. You can also email me. So Allah Hafiz for now, and do take care.